Hey everyone, ready for another deep dive? Today we're going to be tackling something pretty massive, the scale of the universe.
That's right.
And for this one, we'll be using this source here called howbigistheuniverse.txt.
Awesome.
It's a topic that can make you feel, well, incredibly small, but also totally connected to everything.
Yeah, I know what you mean.
So to kind of kick things off, let's start with something a little bit closer to home, our home planet Earth.
Yeah, it's fascinating how Earth, the center of our world, seems so vast from our perspective.
It really does.
But then as we journey outwards, that familiar feeling starts to change dramatically.
Absolutely. We often forget that even reaching the moon, that's our celestial next-door neighbor, involves covering a distance of, well, 384,400 kilometers.
To put that into perspective, imagine hopping in your car and setting off for the moon.
Oh, wow.
Even if you could drive through space at a constant 100 kilometers per hour, it would take you over 160 days to get there.
Nonstop.
Nonstop.
Wow. That's pretty incredible. It really makes you appreciate the journeys undertaken by the Apollo astronauts.
Absolutely. But what's even more remarkable is how the view from the moon actually transforms our perception of Earth. You suddenly see this planet shrink down to the size of a marble, a delicate blue sphere suspended in the vastness of space.
Oh, yeah. It's like that iconic pale blue dot photo taken by Voyager 1.
Right?
Just a tiny speck of light representing everything we know, all of human history contained in a single pixel.
It's incredible.
It really makes you realize just how fragile our planet truly is.
Absolutely. That image sparked a powerful realization, for many a sense of shared responsibility for this little oasis in the vast cosmic ocean.
And it highlights the importance of protecting our planet, our only home.
It really does.
Okay, so we've just scratched the surface of space travel with our trip to the moon. Next, let's shift our focus to the heart of our solar system, the sun.
Okay, sounds good. When we talk about distances in space, we often use a special measuring stick, the astronomical unit, or AU. 1 AU represents the average distance between the Earth and the sun, roughly 150 million kilometers.
Okay, so using this cosmic yardstick, we can start to grasp the immense scale of our solar system. To give you an idea of just how vast this distance is, even light, the fastest thing in the universe takes over 8 minutes to travel from the sun to the Earth.
It's true. And despite that incredible distance, the sun's energy is vital for life on Earth, providing the light and warmth that sustains us.
Right.
It's an example of how interconnected everything is, even across these vast cosmic distances.
Absolutely. Now let's journey to Mars, our red neighbor, and a constant source of fascination for scientists and dreamers alike. Have you ever wondered how long it would take to reach Mars?
Yeah, it's a good question.
Well, it's not a simple answer because the distance between Earth and Mars fluctuates quite a bit.
That's right. Because both planets are constantly orbiting the sun, the distance between them can range from a mere 54.6 million kilometers to a whopping 401 million kilometers.
Wow.
Yeah, this constantly shifting distance is one of the biggest challenges for planning missions to Mars.
So when you hear about those ambitious plans for sending humans to Mars, just remember, it's not just about building a powerful rocket.
Right.
It's about navigating a cosmic dance between two planets, each moving at incredible speeds.
Exactly. And if we were to use our car analogy again,
Oh, yeah.
that trip to Mars could take you anywhere from 3 to 22 years.
Oh, wow.
Depending on the planetary alignment.
Depending on the planetary alignment. Of course, we're assuming you could actually drive through the vacuum of space,
Right.
which isn't exactly practical.
Not yet.
Let's leave that to the sci-fi raiders for now. But speaking of venturing further out, let's make our next stop Neptune, the icy giant, marking the outer boundary of our solar system.
Okay, so now we're about to jump to a staggering 4.5 billion kilometers from Earth. That's 30 times the distance between Earth and the sun.
30 AU.
30 AU.
Wow, that's hard to even picture. And to think it takes sunlight traveling at the speed of light over 4 hours to reach Neptune
It does.
really puts into perspective how vast our solar system truly is.
Yeah. Neptune's discovery back in 1846 was a watershed moment in astronomy.
I can imagine.
It expanded our understanding of the solar system's size, but also revealed this intricate gravitational dance of celestial bodies paving the way for future discoveries about our cosmic neighborhood.
Speaking of venturing far beyond our neighborhood, we have to talk about humanity's most distant emissary, Voyager 1.
Ah, yes. Voyager 1 launched in 1977. It's been on an incredible journey for over 45 years, traveling over 22 billion kilometers from Earth.
Wow, and what's even more remarkable is that Voyager 1 is still sending back data.
It is.
providing invaluable insights about the outermost reaches of our solar system and beyond.
Like having a postcard from the edge of interstellar space.
It really is, and who could
Yeah.
forget that iconic pale blue dot photograph taken at the suggestion of the brilliant Carl Sagan?
Oh, such a powerful image.
That image, a single pixel capturing Earth from a distance of 6 billion kilometers. It changed our perspective on our place in the universe.
Emphasized our shared fragility and the responsibility we have to protect this pale blue dot, the only home we know.
And on that note of venturing to the very edge of our solar system, let's talk about the mysterious Oort cloud.
All right, now we're entering the realm of truly mind-boggling distances.
Okay.
The Oort cloud is a theoretical sphere of icy objects thought to surround our solar system, extending outwards for trillions of kilometers.
Trillions.
Trillions.
To give you an idea of just how far out we're talking, the Oort cloud is estimated to be about 100,000 AU from the sun. That's almost 2 light years away.
And to understand that distance, we need to introduce the concept of a light year, the distance light travels in 1 year, which is about 9.5 trillion kilometers.
So light from the sun takes 8 minutes to reach Earth, 4 hours to reach Neptune, and a whole 2 years to reach the outer edge of the Oort cloud.
Yeah, and the Oort cloud is thought to be sort of transition zone between our solar system and interstellar space, like the cosmic suburbs.
Oh, wow.
A vast and sparsely populated region where the sun's gravitational influence begins to fade.
It really makes you wonder what other secrets are lurking in this distant, icy realm, far beyond the familiar planets of our solar system.
So are you ready to venture even further beyond the confines of our solar system?
Absolutely. But first, I think we all need a moment to process the sheer scale of what we've just covered.
I agree.
From our pale blue dot to the icy depths of the Oort cloud, the distances are truly mind-boggling. But hold on tight, because things are about to get even more expansive as we venture into the realm of interstellar space in the next part of our deep dive.
I can't wait.
Me neither.
Now that we've explored our solar system, let's take a giant leap into interstellar space. Our first stop, Alpha Centauri, the closest star system to our own.
All right, I'm ready to have my mind blown again. Just how far are we talking about here?
Well, Alpha Centauri is about 4.4 light years away, which is actually a relatively short distance on a cosmic scale. But when you convert that to kilometers, it's a staggering 41.3 trillion kilometers.
Trillions. That's just an incomprehensible number. Our trusty astronomical units seem a bit inadequate for these kinds of distances.
No, exactly. When we're dealing with interstellar distances, light years become our go-to measuring stick. And as we've already established, a light year represents the distance light travels in 1 year, an incredible 9.5 trillion kilometers.
So if we were to hop aboard Voyager 1, which is currently zipping along at about 17 kilometers per second, how long would it take us to reach Alpha Centauri?
Let's just say you'd need to pack a lot more than just a few books for that trip.
Oh, wow.
At its current speed, Voyager 1 would take over 70,000 years to reach Alpha Centauri.
Wow, that really puts into perspective the challenges of interstellar travel. The distances involved are so immense that even our fastest spacecraft seem incredibly slow.
It makes you wonder what kind of technology we would need to develop to explore these distant star systems within a human lifetime.
For sure. It's a challenge that sparks the imagination and fuels our desire to push the boundaries of what's possible. But for now, let's set aside the dreams of interstellar travel and shift our focus to something even grander, the Milky Way galaxy.
Okay, our galactic home is a truly awe-inspiring sight. Imagine a vast spiral, a swirling disk of stars, gas, and dust spanning 100,000 light years in diameter.
Wow. Okay, that's just mind-boggling. How many stars are we talking about in this giant cosmic pinwheel?
Hold on tight because this number is hard to grasp. The Milky Way contains hundreds of billions of stars.
Hundreds of billions.
And each one of those stars could potentially have its own planets and maybe even life.
It's humbling to think that our sun is just one star among billions in this massive celestial city. It makes you wonder if there are other civilizations out there looking up at their own night sky and contemplating the same mysteries.
There's an interesting concept related to this called the human radio bubble. It represents the extent to which our radio and television signals have traveled out into space.
So it's like a sphere of radio waves emanating from Earth, carrying our music, our news, our history out into the cosmos.
Exactly.
Yeah.
But here's the catch. This radio bubble only extends about 100 light years from Earth.
Oh, wow.
So for any potential alien civilizations listening in beyond that 100 light year radius, it's as if humanity never even existed.
That's both fascinating and a little eerie. It's like our cosmic shout into the void is only heard by a tiny fraction of the galaxy.
It highlights the limitations of our current technology and makes you wonder how we might one day overcome these vast distances to connect with other civilizations if they're out there.
Now, I understand that the Milky Way, as vast as it is just one of many galaxies in the universe. Where do we go from here in our cosmic zoom out?
Well, our next stop is a group of galaxies known as the local group, a cosmic neighborhood spanning about 10 million light years.
So even galaxies have their own social circles.
Absolutely. The local group is a diverse bunch with spiral galaxies like the Milky Way, elliptical galaxies, and even dwarf galaxies, all held together by their mutual gravitational attraction.
It's incredible to think about these vast structures, these galactic cities interacting and influencing each other across such immense distances.
And it gets even grander. The local group itself is just a small part of an even larger structure called the Virgo supercluster.
Okay, we're talking about superclusters now. My mind is struggling to keep up with these ever-increasing scales.
The Virgo supercluster is a truly colossal structure, about 110 million light years across and containing thousands of galaxies, including our local group. It's like a giant metropolis of galactic clusters.
Thousands of galaxies, each containing billions of stars. The numbers are becoming almost meaningless at this point. And I have to ask, is there anything even bigger than a supercluster?
Get ready for this. The Virgo supercluster, along with countless other superclusters, is part of an even larger cosmic structure known as Laniakea.
Laniakea, what a beautiful and mysterious name. What exactly is Laniakea?
Laniakea is a supercluster of superclusters,
Wow.
if you can imagine that. It's the immense structure that contains our local group, the Virgo supercluster, and countless other galaxies.
So it's like the ultimate cosmic address, Earth solar system, Milky Way galaxy local group, Virgo supercluster, Laniakea. I think I need to update my cosmic GPS. But seriously, how big is Laniakea?
We're talking about a mind-boggling 500 million light years across. It's so vast that it contains trillions upon trillions of stars. To put it into perspective, if the Milky Way were the size of a coffee cup, Laniakea would be the size of North America.
Okay. I'm officially starting to feel incredibly small, but also incredibly connected to this vast, intricate web of cosmic structures. It's like we're all part of this incredible cosmic dance from the smallest particles to the largest superclusters.
That's a beautiful way to put it.
Wow.
And there's a mysterious force at play within Laniakea, a gravitational anomaly known as the Great Attractor.
The Great Attractor, that sounds almost ominous. What is it exactly?
It's a region of space that seems to be pulling everything in Laniakea towards it, including our own Milky Way galaxy. But its exact nature and the source of its immense gravitational pull remain a mystery.
So we have this incredible supercluster Laniakea with trillions upon trillions of stars all being drawn towards this enigmatic Great Attractor. It's like a cosmic thriller unfolding on a scale we can barely comprehend.
It certainly is. And this brings us to the limits of what we can currently observe, the observable universe.
Okay, so we've zoomed out from Earth to the solar system, the Milky Way, the local group, the Virgo supercluster, and now to Laniakea. Is this the ultimate edge, the final frontier of the cosmos?
Well, the observable universe encompasses everything we can currently detect, all the light that has had time to reach us since the Big Bang. And we're talking about a staggering 93 billion light years in diameter.
Wait, 93 billion light years? But I thought the universe was only about 13.8 billion years old. How is that possible?
That's a great question. The key lies in the fact that the universe has been expanding since the Big Bang.
Right.
Space itself is stretching, carrying galaxies away from each other like dots on an inflating balloon.
So some of these galaxies are so far away that their light has been traveling towards us for almost the entire age of the universe.
Yeah, here's the mind-blowing part.
Yeah.
Some galaxies are moving away from us faster than the speed of light. This means that there might be entire galaxies, entire regions of the universe that we'll never be able to see because their light will never reach us.
That's just incredible. So the observable universe might be just a tiny fraction of what's actually out there. The universe is even more immense and mysterious than we can possibly imagine.
That's the beauty and wonder of cosmology. The more we learn, the more we realize how much more there is to discover. And speaking of discoveries, there are some truly mind-bending concepts that we haven't even touched on yet, like dark matter and dark energy.
I was wondering when those would come up. It seems like every time we answer one question about the universe, a dozen more pop up.
That's the nature of scientific exploration. It's a never-ending quest for knowledge, driven by our insatiable curiosity and our desire to understand our place in this vast and mysterious cosmos.
Well, on that note, I think it's time to take a step back and reflect on the incredible journey we've taken so far. We've covered some serious cosmic ground from our pale blue dot to the edge of the observable universe, It's been an awe-inspiring experience, to say the least.
Yeah.
Okay, so as we wrap up our deep dive into the scale of the universe, it's kind of crazy to think about where we started. We began right here on Earth,
Right.
a planet that feels so vast and familiar to us.
Yeah.
And yet when we zoom out, we see that Earth is just a tiny speck of dust in the grand scheme of things.
From that tiny speck, we ventured out to our celestial neighbor, the moon, and then to our life-giving star, the sun. We explored the diverse planets of our solar system, each a unique world with its own story to tell. And then we pushed beyond the familiar, venturing into the realm of interstellar space, where distances are measured in light years.
And it's incredible how quickly those distances escalated. We went from thinking about kilometers to astronomical units to light years,
Right.
each jump representing a mind-boggling increase in scale.
And even with light years as our measuring stick, the distances continue to grow exponentially. We explored the vastness of the Milky Way galaxy, our home among hundreds of billions of stars. And we learned that even within this enormous structure, our human radio bubble only extends a tiny fraction of the way.
It's a humbling thought, isn't it? Beyond that 100-light-year radius, it's as if humanity never even existed.
It is, but then we zoomed out even further, exploring the local group, a cluster of galaxies bound together by gravity.
Right.
And then we encountered the Virgo supercluster, a truly colossal structure containing thousands of galaxies. And finally, we reached the mind-boggling scale of Laniakea, a supercluster of superclusters spanning 500 million light-years.
It's hard to even wrap your head around those kinds of distances. And the fact that all of this, everything we've talked about, is just part of the observable universe, which itself might be just a tiny fraction of the entire universe, well, it's enough to make you feel incredibly small.
And yet, at the same time, it also makes you feel incredibly connected to something much greater than yourself. We are all part of this vast, intricate web of cosmic structures, from the smallest particles to the largest superclusters.
So what stood out to you most during our exploration of these mind-blowing scales?
I think for me, it's the realization that we are still just scratching the surface of what we know about the universe.
Yeah.
Every new discovery, every new observation seems to open up even more questions and mysteries.
That's so true. And it's exciting to think about all the amazing discoveries that await us in the future as we continue to explore the cosmos.
And perhaps as we delve deeper into the mysteries of the universe, we'll also gain a deeper understanding of our own place within it.
I like that.
We might even find answers to some of the most fundamental questions about our existence. Where did we come from? Are we alone in the universe? What is the ultimate fate of the cosmos?
It's a journey that requires both humility and a sense of wonder.
Yeah.
We have to acknowledge the vastness of what we don't know, while at the same time embracing the thrill of discovery and the beauty of the unknown.
It's a journey that we all share as inhabitants of this pale blue dot hurtling through space on this incredible cosmic adventure.
Well said. As we wrap up our deep dive, I hope you're leaving with a sense of awe and a renewed appreciation for the incredible scale and mystery of the universe we inhabit.
Keep looking up, keep asking questions, and never stop exploring. The cosmos is full of wonders waiting to be discovered.
Until next time, keep those minds expanding.